Next, we are going to study about computer tomography. Computer tomography is otherwise called as CT. It is a medical imaging procedure that utilizes computer processed X-rays to produce tomographic images or slices of specific areas of the body. They are used for diagnostic and therapeutic purposes, and it enables direct imaging and differentiation of soft tissue structures such as liver, lung, tissue and fat. The basic principle of CT is that the internal structure of an object can be reconstructed from multiple projections of the object. It is a systematic collection and representation of projected data. As usually know, in CT, the cross-section portion of body which is scanned for production of CT image is called slice. The slice has a width and therefore it also has a volume. By taking an example of a bread, it can be things like looking into the loaf of bread and by cutting it into thin slices and then viewing the slice individually. It is the same principle is appearing or occurring in CT. Then when we compare CT with conventional radiography or X-ray, in first figure is a conventional radiography figure. It suffers from collapsing of 3D structures into a two-dimensional image. The second figure is the same structure taken through CT and it gives accurate diagnostic information about the distribution of structures inside the body. Another difference is that a conventional X-ray image is a shadow, but shadow gives only an incomplete picture of an object shape. But in a CT scan machine, the X-ray beam moves all around the patient, scanning from hundreds of different angles, taking different projections or different images. And this is the CT scanning machine. And the components in CT scanner for basic steps of CT scanning are X-ray production, data acquisition, then data processing or reconstruction of the obtained data and the image display. This is the basic block diagram of CT scanning machine. It consists in CT, X-rays from a finely collimated source are made to pass through a slice of the object or patient from a variety of directions. This X-ray tube is there, collimator is there, measuring electronics is there and video monitor is there. And the first step is data acquisition. The scanning process begins with data acquisition. It is a method by which the patient is systematically scanned by the X-ray tube and detectors to collect enough information for image reconstruction. A basic data acquisition scheme consists of X-ray tube, filters, collimators and detectors. The collimators converts X-rays into a very pencil thin beam. Detectors absorb the X-ray photons and emit energy as visible light. It also consists of a photomultiplier tube that converts the photons to electrons. Analog outputs from these tubes goes to signal conditioning circuitry that amplifies, clips and shapes the signals. And this is the block diagram. It is explained by a single ray. A ray is the pathway of a portion of the X-ray beam from one specific focus port position to specific detector position. A view is made up of many individual rays. This X-ray tube is rotated around the patient's body. Many views projected from around the patient's body are required to acquire the necessary data to reconstruct an image. The projection of the fan-shaped X-ray beam from one specific X-ray tube focus port position produces one view. And many number of single views produces a large image. As the X-ray beam is scanned around the body forming many views as shown in the figure, the data recorded by the detectors are stored in computer memory for later image reconstruction. And Computer tomography involves the determination of attenuation characteristics for each small volume of tissue in the patient's slice. What do you mean by attenuation? Attenuation means it is obtained by measuring and comparing the incident and transmitted X-ray intensities. If a material is more dense or an organ is more dense, it transmits lesser X-rays, and if the material or organ is less dense, it transmits more X-rays. And the degree of attenuation is obtained by measuring and comparing the incident and transmitted X-rays. Attenuation coefficient is a measure of how rapidly X-rays are absorbed within a material. And this is the block. Central 4 blocks represents an internal object, and each voxel having its own attenuation coefficient. The sum of voxel attenuation coefficient for each X-ray beam direction can be determined for each voxel width. In conclusion, a measurement made by a CT detector is proportional to sum of the attenuation coefficient. It is these calculated attenuation characteristics that actually compose the CT image. And it is reconstructed by back projection method. In back projection method, when the rays from the two projections are superimposed or back projected, they produce a crude reproduction of the original object. In practice, many projections would be added to improve image quality. If we get many projections of the same object, the image quality will be improved and we get a better image of the projected object. Advantages of CT scanning are they are relatively inexpensive compared with MRI scanning, accurate three-dimensional data including attenuation information, rapid acquisition of data, and no need for patients to remain for planning process. Thank you.